I want to look at 2 or 3-dimensional spaces. And so I want to start with the polar coordinates. I want to start with the polar coordinates. All right. Right. Now, if we look at this figure, we see that we have the right-angled triangle, and we have our hypotenuse, our R, the x-axis, then the y. So this side is x, this side is y. Now, from this figure, we'll be able to come out with our trig ratios. So you have our cos theta given as the adjacent over hypotenuse x on R, sine theta giving us our opposite over hypotenuse, so y on R. So with this established, we can now make our x the subject, where we get our x equals R cos theta, make our y the subject, where we get y equals R sine theta. So that is established from polar coordinates. And because we have the right angle triangle, we can use the Pythagoras theorem. And so our R squared will be the sum of S squared and then Y squared. So we have it this way. Now, with our angle here, with this angle theta, we can say that then our tan theta will give us our Y on X, opposite over adjacent. So we can also use this to compute our tan theta, right? So let's look at some examples. Convert the point 2 pi on 3 from polar to Cartesian coordinates, from polar to Cartesian coordinates. And so we are going to write it in the form r theta. Right, so from the question, we have this. We've seen that our r is 2, and then we can now get our theta to be pi on 3. Then from the known concepts that we know, so our x will be equal to r cos theta, so 2 dot half, that is cos. Pi on 3 will give us that value. All right, so once we put pi on 3 here, and then r sine theta for y, we get 2 dot root 3 on 2, then we get root 3. Now, so the point we are looking for is 1 root 3. So our x is 1, our y is root 3 in the Cartesian coordinates. So look at the solution again. Let's look at the second question. Represent the point with Cartesian coordinates 1, -1 in terms of polar coordinates. So we are going to do same with the concepts that we have just outlined. So we say that let R be positive. Let our R be positive so that right away we can use our Cartesian coordinates in finding our R. So we say that our x squared, the negative our y squared, so we shall get 1 squared plus -1 all squared. So we get our root 2 for R. We all know that our tan theta is y on x. And so our y on x, -1 over 1 will give us our tan theta being -1. Now, our 1 and then -1 is actually in the 4th quadrant. If we want to sketch, we'll find that in the 4th quadrant. So we will say that it means that our theta will be -pi on 4 or 7 pi on 4. And so then we can now write our polar coordinates in terms of these values. All right. So we have our r to be root 2. And so we have root 2, then the pi on 4, or we also have it this way so that we can now actually move on. So that does it for this question. That's great. So look at this question again. Look at it carefully and see. Right. Now this established, we are now moving on to cylindrical coordinates. Cylindrical coordinates. And so from our 3-dimensional figure, see now we have the x coordinate, our y coordinate, and then our z. Then we have our z here. Then the angle over here is theta. and then we have our R, and then we have our point P, and that is expressed in terms of R, theta, and Z. R, theta, and Z in terms of the cylindrical coordinates. Now, let's try to derive some important things over here. We will recall that our X is given by this, our Y is given by that, and our Z also gives us still our Z, where our R squared gives us S squared plus Y squared. Our tan theta is Y on X. Our Z still gives us our Z. So take note of these important concepts, which we'll be recalling and using them in our various examples and questions. So we are treating cylindrical coordinates. Let's look at some examples. Find the rectangular coordinates of the cylindrical coordinates 2, 2 pi on 3, and then 1. So we are converting everything in terms of, that is our rectangular coordinates x, y, and z. Our x is 2 cos 2 pi on 3, so we can get 2 into negative half, and that gives us negative 1. Then our y, 2 sine 2 pi on 3, and that will actually give us 2 times root 3 on 2, that is root 3. So we've gotten our y, our x, and then our z from the question is also 1. And so the set of rectangular coordinates is neg 1, root 3, and then 1. Fantastic. Okay, so let's go back, take your time and look at the question. We're given cylindrical coordinates. If you come back to the original, you see that we have our point to be r, theta, and z. Good. And so these points are in that. All right, so look at the solution again. And then the final. All right, let's go to another question. Find the cylindrical coordinates of the point with rectangular coordinates 3, neg 3, neg 7. So we'll move on to see how we can do that. Rather, we need to find our R. We have our X and Y. So X3, our Y3, now Z is, that is X is 3, Y is neg 3, our Z is neg 7. So to compute our R, we get 3 squared plus negative 3 also squared. And when we compute that, we shall get 3 root 2. Okay, so our tan theta is neg 3 on 3, and that is negative 1. And so here our theta will be 7 pi on 4, and that's multiples of that. And so we can move on and on. And then our z is negative 7. So we'll say that the set of cylindrical coordinates under review are 3 root 2, 7 pi on 4 minus 7, or 3 root 2, negative pi on 4 minus 7. So these are the, so you could see that whichever way you go in the Cartesian plane, you will get either in clockwise or anti-clockwise, you get the answer. So that does it. So look at this question as well. Right. Let's move on to spherical coordinates and look at the diagram. Look at the figure. Look at the figure. Look at the figure. So from the figure, we have our phi, we have our theta, we have our r. And then in terms of the Cartesian, then in terms of spherical coordinates is rho theta phi, rho theta phi. All right, good. Now, so let's now compute them. So from the diagram, our z, the diagram, we can just get our z straight away. Then our z is rho cos theta, sorry, rho cos phi. R is rho sine phi Then x, as we know, recall, r cos theta, and then y, r sine theta. All right, so we can capture them this way. Now, you could see that from x equals r cos theta, we can replace the r with rho sine phi. And when we do that, we get our s giving us this, and then our y giving us the whole of that, with our z giving us rho cos phi. All right, good. Now, our rho will also give us s squared plus y squared plus z squared from the diagram as well. So take note of this for the spherical coordinates. With this established, let's take our time and look at some questions. The point 2, pi 4, pi 3 is given in spherical coordinates. Find its rectangular coordinates. All right, so we can just do a sketch. So when we sketch, this is how the whole thing will be. Right, so now let's go to the question. So our x will be rho sine phi cos theta. So we get our 2 sine pi on 3 cos pi on 4. Then when we compute, we shall get root 3 on 2. For our y, we get our rho sine phi sine theta. So when we compute 2 sine pi on 3 sine pi on 4, so we shall get our value root 3 on 2 because these are standard values for them. Then our z is rho cos phi, so that is 2 cos pi on 3. So we get our 2 times half, giving us 1. So the point is root 3 on 2, root 3 on 2, 1 in rectangular coordinates. Our x, our y, and our z. Great. So let's go back, take your time and go through the question again. This is how we derive them. The spherical coordinates. Spherical coordinates. So we have our z here. We also have our z. This also z. And this is right angle triangle, so we can actually move on. All right. Then we also have our theta here. Okay. Then we look at this concept, very important for our spherical coordinates. And then the example I've just explained. This is a sketch. Remember our r is 2. So that's why I have the 2 over here. Right, so the point gives us this in rectangular coordinates. All right, so try this. The point 0, 2, 3, neg 2 is given as rectangular coordinates. Find the spherical coordinates for the point. Find the spherical coordinate for the point. So try that question. Given you the next 3 minutes, you try that. All right, so I'll take you through again. I have the solution down here. So I'll take you through again the next time we meet to revise. Thank you so very much for your time. Keep revising. Have a blessed day. Bye for now.